In this podcast, we're going to talk about the domain of a function. The domain is a concept of what x it's legally allowed to put into a function. Formally, we say the number x is in the domain of the function y equals f of x if f of x is defined, that is, if f of x exists. So the domain of a function is all the x's that you could put into the formula for the function and not run into any trouble. So what causes trouble when you put in an x? Well, there are two things that make something undefined as far as a math expression goes. The first thing that would make a math expression undefined is division by 0. 0 divided by 5, that is, dividing a number into 0, is okay. You just get 0. But 5 divided by 0, we say, is undefined. And undefined means it just simply has no meaning in math. So one of the things that you have to look for when you're looking for the domain of a function is making sure that no choice of x causes you to be dividing by 0. The second thing that would make something undefined in math is you can't take even roots of negative numbers. So negative the square root of 16 is okay because I'm taking the square root of the positive number 16 and I get 4. It just so happens that there's a negative in front, so the final simplification of this would be negative 4. However, if I try to do this, take the square root of negative 16, that is undefined. It's okay to have a negative outside the square root, but you cannot have a negative inside the square root. It's okay to have a 0 on the top, but you cannot have a 0 on the bottom. Now, with that in mind, let's take a look at some domains. And example 1 says, find the domain of the function f of x equals x over x minus 2 times x plus 1. If I let x equals 2, then I would have f of x equals 2 over 2 minus 2 times 2 plus 1. This would be 2 over 0 times 3. Well, 0 times 3 is 0, so that would be 2 over 0, and I would be dividing by 0. So because of this 2 in the denominator here, for x equals 2, you could not allow x to be 2 because it would cause you to divide by 0. By the same logic, you could not let x be negative 1, because if x was negative 1, this expression would be negative 1 plus 1, which would be 0. So again, I'd have a 0 in the denominator of a fraction. That's not allowed. So here's how we write the domain. We say the domain of f can be any number. So I write this curly bracket to mean the set of all. And it's the set of all x such that. The vertical line means such that. Or with the following properties. We've determined in the first example here that x can't be 2. So I would say x cannot be 2. And we determined in the second part that x could not be negative 1. So I would say r negative 1. So the domain of f is the set of all numbers such that the numbers are not a 2 or a negative 1. Well, that's a huge domain. It's every single number you can think of except for those two numbers. Now you might say, well, could x be 0? Well, yes, if x was 0, you'd have 0 on the top, which we said was okay. 0 on the top is fine. If you had x equals 0 on the bottom would be negative 2 times 1, because 0 plus 1 is 1. So that would be 0 over negative 2, and that's okay. That would just be 0. So yes, it is okay for x to be 0. A 0 on the top doesn't hurt anything. It's zeros on the bottom that you have to get rid of. Now let's take a look at a second example. It says, find the domain of g if g of x is 3 over x minus 1 plus 5 over x plus 2 plus x minus 3 over 4. Well, here's the principle that we're going to work on. if any part of an expression, and this is an expression of three terms separated by plus signs, if any part of an expression is undefined, the expression is undefined. So in particular, I cannot let x be 1, because if x was 1, this first part of the expression, this first term, would be undefined because I'd have 3 over 1 minus 1, which puts a 0 on the bottom. Also, x cannot be negative 2. Because if I let x be negative 2, this would be 5 over negative 2 plus 2. That's 5 over 0, which means this term would be undefined, which means the entire expression would be undefined. Now what about x equals 3? Well, x equals 3 is okay, because even though that makes a 0, it makes it on the top. And zeros on the top are okay. It's zeros on the bottom that you have to avoid. So here's how we would answer the question on the domain. We would say the domain of G is equal to the set of all x such that x cannot be 1, because that would make the first term undefined and therefore the entire expression undefined, and x cannot be negative 2, because that would make the second term undefined and therefore the entire expression would be undefined. Now as far as x equals 3, that's fine. That puts a 0 on the top. On this denominator, if x was 3, you'd have 3 halves, which is perfectly okay. In this denominator, if x was 3, the bottom would be 3 plus 2, which is 5, so this would just be 5 over 5, which is 1. So letting x be 3 is perfectly okay, because the 0 that generates is on the top and not on the bottom. Let's go on to the third example. Now the third example goes on to point 2. In point 2 says you can't take even roots of negative numbers. It's okay to take even roots of positive numbers, but not negative numbers. And the square root is an even root. It's the second root. Okay, so we're talking about here taking an even root. So let's think about what cannot happen. We cannot let ourselves be taking an even root of a negative number. Now what are we taking the root of here? We're not taking the root of x. We're taking the root of everything in the root sign. We're taking the root of 2x minus 1. So it's 2x minus 1 that we have to deal with. Now what do we say about 2x minus 1? Well, we say it cannot be negative. One way to write that would be like this: cannot be less than 0. But that's usually not what we write. We think about a number. Every number is either positive, negative, or 0. So if it's not negative, that leaves us two other choices. 2x minus 1 could be positive, that means greater than 0, or 2x minus 1 could be equal to 0. And both of those are not negative. Now if we just solve this, we will have the domain of f of x. So I'm going to solve this for x. First I'll move 1 to the other side. 2x is greater than or equal to 1. Then I'll divide both sides by 2. X is greater than or equal to a half. So we would say that in order for us to not divide by 0, x would have to be greater than or equal to a half. So for example, if x was 1, which is greater than or equal to a half, this would be 2 minus 1, which would be 1, so I'd be taking the square root of a positive number. Now what about this second part? Does that also have to be greater than or equal to 0? Well, no, I'm not taking the square root of it. This can be positive or negative. It doesn't make any difference at all. It's just a number. We're not taking a square root. So in our final answer to this, we would say the domain of f is the set of x such that x has to be greater than or equal to 1/2. Now, I wrote number 4, example 4, to be almost like example 3. Notice I still have a root of the same thing, 2x minus 1, that I had in the previous example. But I did something slightly different. Instead of having the square root of 2x minus 1 on the top, like an example, and by the way, you don't leave this here. It is a second root, but you don't write it there. If you just leave it blank, that's a 2 right there. If I move that root to the bottom, it's no longer allowable to make it equal to 0. It's okay for this square root to be greater than 0, or for the 2x minus 1 to be greater, but now if the 2x minus 1 is equal to 0, which was okay in example 3 because it was on the top, it's not okay here. Because if 2x minus 1 is 0, the square root of 0 is also 0. And I would be dividing by 0, and that's not allowed. So what I have to do here is get rid of that condition that said it was okay for it to be equal to 0. That's not okay anymore. So now I would say 2x minus 1 has to be strictly greater than 0. But I solve it the same way. I just get x is strictly greater than a half. So I would say the domain of G is equal to the set of x such that x is greater than a half instead of, like in the previous problem, greater than or equal to a half. And again, we had to get rid of the equal sign because this time the square root was on the bottom, not on the top. And now to our final example. In the final example, we combine the first case problems where you couldn't divide by 0 with the second case problems that you can't take even roots of negative numbers. So let's see what we get. We'll handle the square root first. We know that x minus 2 cannot be, we know that x plus 2 cannot be negative because you can't take the even root of a negative. So I'm going to say x plus 2 has to either be positive, has to either be greater than 0, or it has to be equal to 0 because it can't be less than 0. I move the 2 to the other side and I get x is greater than or equal to negative 2. Now I go to the second case. In the second case, I am not allowed to have x equals negative 3. I'm not allowed to have that because if x was negative 3, the bottom would be negative 3 plus 3, which is 0, and you can't have 0 on the bottom. So this leads me to the conclusion that x is not negative 3. Notice the difference. In the square root case, we're talking about a lot more than one value of x. We're saying x can't be any number bigger than negative 2. That's a whole infinity of numbers that we've ruled out. Whereas without the square root, we're only ruling out one number, and that's the number negative 3. Any other number is okay for this second term. And in the third term, we say x cannot be 5. Because if it was, we'd have 5 minus 5 on the bottom, and we would be dividing by 0. Now, how do we put these all together into a domain statement? Well, I could say the domain of f is the set of x such that the following occurs. First off, x has to be greater than or equal to negative 2. Now that throws out a whole infinity of numbers corresponding to the square root. Now let's look at our two single cases. If x was negative 3, negative 3 is not bigger than or equal to negative 2, so it has already been excluded from the set by this condition. In other words, if x is bigger than or equal to negative 2, it's already not negative 3. Now, I'm not saying that it's wrong to put x is unequal to negative 3 in here, but it would be redundant. You've already said right here that x is not equal to negative 3, so putting it again would just be repeating yourself. However, 5 is bigger than negative 2. So this condition, this first condition, allows x to be 5. So since the third condition says that x can't be 5, we must include that and say x is unequal to 5. You could say that with a comma, or you could say that with the word and. You could say x is greater than or equal to negative 2 and x is unequal to 5. Now once again, if I threw in and x is unequal to negative 3, it would not make it wrong. I would not take off points. However, that would be redundant. You already said here that x was not negative 3. And that completes our podcast on domain.